All right, welcome to The Explainer. Today, we're not just going to talk about the brain, we're going to do a full systems analysis on its reward pathway. I want you to think of it like it's the oldest operating system in the world, and we're about to figure out its core logic, how to debug its errors, and ultimately, how to write some better code for it.
Okay, let's just dive right into this quote. We're kicking things off with a pretty critical vulnerability in our system. You could almost call it a zero-day exploit, and it's being leveraged against us by the very devices we carry around in our pockets. And look, that's not just a clever metaphor. This is the central bug we're up against.
You know, our brain's reward system is basically ancient legacy hardware. It was designed for a world that just doesn't exist anymore. And because of that, it's facing a critical bug caused by the constant input of our modern world, a massive, massive dopamine overload. So what's at the heart of this problem? Well, it's this huge environmental mismatch. Our internal system was coded for a world of scarcity, a place where rewards were pretty rare and you had to work for them. But today, we're living in a world of just overwhelming abundance, and our OS is really struggling to process this constant flood of high-reward stuff. And this is the stuff that's causing the overload. You've got processed foods, the infinite scroll on social media, one-click shopping. All of these are sources of what we can call cheap dopamine. They give you this instant, really potent reward with almost no effort, and that forces our brain's OS into a state of chronic overstimulation that it was just never built for. So what happens when you just flood a system with too much input? Well, it tries to protect itself, right? Imagine your brain has a limited number of, let's say, parking spots or receptors for dopamine. When there's a constant traffic jam of stimulation, the system starts closing off some of those spots just to manage the flow. This is called downregulation. But this defensive move, it has a pretty severe unintended consequence. It leads to a critical error state.
All right, so here's the crucial part. To debug this whole system, we first have to understand the core algorithm that runs it. And that algorithm is built on a really simple but incredibly powerful balance, the dynamic between pleasure and pain. And this isn't some kind of philosophy. It's fundamental neuroscientific code. It's called the opponent process theory. Basically, the system's main job, its prime directive, is to keep everything stable, what's known as homeostasis. So for every single signal it receives, it generates an equal and opposite countersignal to get back to its baseline. The best way to picture this is to imagine a perfectly balanced seesaw. Every hit of that cheap dopamine, every sugary snack, every social media like, violently shoves the pleasure side down. But the algorithm won't let it stay there. To restore that balance, it pushes back with an equal, and often slightly greater, weight on the pain side. Now, what's really interesting here is how this visualizes the entire failure cascade. So you start off balanced, right? Homeostasis. Then, boom, you hit it with a pleasure stimulus. The system reacts with a pain signal to compensate. But when you do that over and over, that chronic use makes the system overcorrect so much that the seesaw actually gets stuck, tilting towards the pain side by default. And that is the system bug in action. You enter what's called a dopamine deficit state. Ever wonder why, after a weekend of binge watching a show and eating junk food, you might feel kind of down and unmotivated on Monday morning? That's the deficit state. Your brain's baseline has literally been rewired to a state of constant low-grade pain, anxiety, and just an inability to feel pleasure from normal everyday things. So that brings us to the obvious question, right? If our system is stuck in this error state, this deficit loop, how do we force a reboot? Well, the answer is a bit counterintuitive, but it's an incredibly powerful built-in feature of our brain's operating system. So how do we fix this? The answer is, well, it's actually kind of elegant. It lies in a concept called hormesis. This is where we stop trying to hack the system with pleasure, and instead we use a totally different input to trigger a full system reset, controlled, self-imposed stress. I want you to think of this as using a feature, not exploiting a bug. With hormesis, we're intentionally pressing on the pain side of that seesaw. And why would you do that? Because we know how the OS works now. When we introduce a controlled stressor, the brain's homeostatic algorithm responds by pushing back hard on the pleasure side to compensate, which effectively resets the whole balance. You're using pain to treat pain. A perfect example of this system reboot in action is exposure to cold water, and the data on how this affects our neurochemistry is absolutely remarkable. Let's just look at the raw numbers. First, get this. Studies show that immersing your body in cold water can trigger a massive homeostatic response, increasing plasma dopamine concentrations by 250%.
And it doesn't even stop there. I mean, this just perfectly shows you the power of that response. Norepinephrine, a neurotransmitter that's crucial for focus, mood, and just being alert, can increase by over 500%. This is the system literally flooding itself with restorative chemical.
And this comparison is so important. Unlike that direct spike and crash you get from cheap dopamine, the release from a hormetic stressor is indirect and gradual. It's sustained for hours, not minutes. And most importantly, the effect it has is actually restorative. It helps upregulate your dopamine receptors, resetting your baseline and pulling you out of that deficit state. It's a system restore, not a system drain. Okay, so a neurochemical reboot, that's incredibly powerful. But think about it. What happens if you just reboot a computer that has a virus? It just gets infected all over again, right? The hardware reset is only half the battle. We also need to patch the underlying psychological code that led to the crash in the first place. And this is where we install a new protocol called radical honesty. So if hormesis is the hard reboot that resets your neurochemistry, then you can think of radical honesty as the software patch that keeps the system stable afterward. It's all about grounding yourself in reality to avoid those feedback loops that cause the overload to begin with. This quote really gets right to the core of the psychological problem. Lying. Even the small stuff, the stuff you just leave out. It creates this disconnect from reality, and that disconnect is what fuels the craving and the compulsive cycle of overconsumption that threw our system out of balance. We all kind of operate with these two selves. You've got the false self, right? That's the curated version of you, the one you show everyone else, and it's maintained by this constant stream of tiny lies and things you omit. Radical honesty is just the protocol for closing the gap between that and your authentic self, the real you, the one that's tethered to reality.
So what's the bottom line here? It's that being honest, even when it feels like a short-term pain, acts as this powerful grounding protocol. It lessens the massive cognitive load it takes to maintain lies, which frees up your system's resources and tethers you to your actual, real existence. So when you understand the system's logic, really understand it, the pleasure-pain algorithm, the bug of dopamine overload, and that reboot feature of hormesis, you can move from being passively run by your programming to actively writing the next line of code. The hardware is a given, but the code we run on it, that's up to us.